have the three speakers that were just there. We will take questions. There's some seats over there. I'm going to move the phone over so those who are online can actually listen to what you guys are saying. And we're going to have a short question and answer period. Sorry. So if you can repeat the question into the phone for those who are online, that'd be great. So, yes, and if you have questions, if you're online, you have questions, please put them in the chat box. We have someone here who's looking, who's actually receiving those and can ask your questions to the speakers as well. So, start up front.
Hi, I have a question for Dr. Grosell. When you tag have you ever tagged your captive mahi and done a swim test on them to see if it affects their cardio function and other things like that?
So I'm going to repeat the question just to make sure you all have it. The question is whether we have looked at swim performance in captivity on animals that are tagged. And, you know, you're getting at whether the tag is slowing them down, basically.
Yeah, or just upsetting their spirituality or whatever.
Yeah. No, we've not done that. It's a great question because there will be some drag from this tag. Yeah. And one concern we have is, on one hand, we want to tag animals that are as large as possible because the weight of the tag and the drag of the tag is going to be less of an issue for a larger animal. The flip side of that is we know that the larger the animal, the more poorly they deal with the handling. So these animals are so powerful and they fight so hard that when they're very, very big, they literally just, they kind of blow up, kind of thing. So we have to kind of, it's sort of a compromise there. So on one hand, we want smaller fish. On the other hand, we don't want the tag to be a large fraction of their mass. There's no doubt it's going to affect them. The hope is that it doesn't affect them enough that we cannot get the type of information that I just discussed.
Share.
So you have acceleration data for when they're feeding and also for when they're spawning, but do you have the same data from when they're avoiding predation?
So the question is whether I showed data. I implied that we have data for accelerations during feeding and spawning events, and we do have that. The question is whether we have that information for predation events. We don't, or attempted predation events. We don't have that. That's really hard to do in captivity, as you can imagine. It would be a great experiment to do, but that's challenging. We don't have that, and so again, what you're getting at, I guess, is that we will see some knockdown data in the acceleration data that may not be related to feeding. It may be related to predator avoidance. But when it comes to analyzing this data, we're going to have to see how that goes. If the fish is consumed by a predator, there are different ways that we may be able to detect that. So, for example, I mentioned that these tags are recording light. If you're ingested by a larger animal, there's going to be no light from the tag, right? So that would be an indication that this animal was indeed preyed upon. So there are examples where we'll be able to sort of separate those type of activities. You can also say that if you have a knockdown event that looks like a feeding event but could be a predation event, and the tag is just drifting with the current after that, again you have some indication that it could have been an event of an interaction with a predator rather than preying.
So, question from the 46 people online. Just one question so far. But this is for Dr. Asper. When measuring the sinking speed of marine snow, you mentioned that one of the discoveries was that these particles were stirred up sediments from the bottom. I was wondering how deep was this one?
The question is, with the sinking speeds of marine snow that were determined using that moored camera system, how deep was it? And also, I'll tell you how high up off the bottom. It was in about we've done it several times, but it's about 1,500 meters of water, and it was only about 60 meters above the bottom, 60. So that coupled with the current meter data that we have there lead us to conclude that this is material that was stirred up from the bottom.
My question's for Steve.
Mm-hmm.
What's the limiting factor with the drone technology? Is that more environmental or your flight time?
You're talking about the aerial drone or the yeah, it's lifetime. The question was, what's the limiting technology or the limiting factor for the aerial drones? It's battery life, how long you can keep it going. But I think that's why an application, on a response vessel where they could fly out and come back, within a fairly small radius would be a fairly effective way of doing that. But that wasn't my drone. This is water mapping, Garcia. Yeah, and it's a commercial off-the-shelf technology. Yeah.
With the marine snow, just simply because of the use of dispersants, or is that a naturally occurring phenomenon?
The question is about marine snow, whether it was caused by the introduction of dispersants or whether it's a natural phenomenon. It's very natural. We see it all over the place, sometimes more, sometimes less. It's not terribly well understood, even though we've been studying it for decades, simply because it's delicate. It's mostly composed of this mucousy material with all kinds of other things stuck into it. And it forms when there's a lot of plankton, when there's certain physical events, when who knows what that form it. And interestingly enough, what happens when you get even light mucousy stuff, if you stick enough other things onto it, it gets dense enough that it can sink. It's sort of a phenomenon sort of like clouds. Clouds are composed of little tiny water droplets that aren't going anywhere. They're basically suspended. You take enough of those water droplets and you coalesce them into a raindrop and it sinks. Marine snow does exactly the same thing in the ocean. You take a lot of little particles, stick them all together, and it sinks out. And it happens pretty much everywhere, pretty much all the time, but never like that. We've never witnessed it like that anyway.
My question is for Dr. MacDonald. Were you able to use remote sensing and or satellite imaging to determine the location and amount of dispersants that were used?
The question is, did we use remote sensing to determine the amount of dispersants we used? No, we didn't. The records of dispersants are really quite good for Deepwater Horizon. So we did take the flight line data, and my lab processed those data and integrated how much dispersant was sprayed from the aircraft, and then we took the data that was compiled by BP to figure out how much was subsea injected. So the records on dispersant application were actually pretty good, although they were fairly dispersed, fairly difficult to boil down, but we did that, and so we didn't have to. We were not able to see that. I showed a picture of a remote sensing image, actually an aerial remote sensing image, over the spill, and that was an experiment done to prove the efficacy of the subsea surf injection, which was done initially because the conditions for the responders were so horrible on the surface. The fumes from the smell was making it very, very difficult to work, and they were able to demonstrate that the subsea dispersants made it more bearable. So there was a good reason and good data to show that it was effective before the large-scale dispersant injection started in early June.
This is a silly question for Dr. Asper. The device that you were using to capture marine snow was only getting the stuff that was settling. Have you tried putting the pipe the other way to see what was going up?
The question is, the marine snow collecting device only gets the ones going down. Have you ever done it to measure the ones going up? No, we would love to do that. In fact, that is something we love to do in the ocean in general. It's just really, really hard, because even if you set it in place and these things are going up there, how do you get it back and know what you've got? I mean, we could devise some sort of a sealing mechanism. So far, to my knowledge, it has been done maybe in very small instances, but with very equivocal or indecisive results. In this case, we really should have done something like that. In retrospect, we would do a lot of things differently. We would use our techniques a little bit differently, and that's something that would be just great to do. Good question.
This is for Dr. Grosell. So you mentioned the death of tunas as well. Are you planning to test the strategy that you put the mahi on the tunas, or are you going to have a different approach to finding out?
So the question is, you've worked on mahi, what about tunas? And we actually have done work on yellowfin tuna. There's work published on bluefin tuna as well. And when you compare yellowfin tuna, bluefin tuna, and mahi, they are roughly at the same level of sensitivity. So in that sense, what we're doing on mahi sort of applies broadly to pelagics, or at least the pelagics that people really care about. Now, as you can imagine, having tuna in captivity is demanding. We actually worked on yellowfin tuna in Panama for that reason. That's one of the few places in the world where they have yellowfin tuna in captivity and where yellowfin tuna is spawning. You know, but it's a long haul to get there, and when you're there, you're sort of in the middle of nowhere. So the technology that we rely on for these kind of experiments, you know, it's very difficult to sort of have that in a place where you have access to the tuna embryos. Now, I mentioned that mahi and tuna in some sense are similar because the sensitivity of the early life stage is comparable. One issue that I alluded to is that mahi have a very fast life cycle. So they sexually mature in 3 to 4 months. They live 2 or 3 years, and that's it. And what that means is that those populations have a very high potential for regeneration. They produce a lot of offspring. They get to sexual maturity fast. So any impact on their populations due to, say, a disaster like this will be seen quickly. And if not, then you have a good reason to believe that there's not long-term effects. The opposite is true for tunas. Bluefin tuna will be 10 to 20 years old before they contribute to the spawning population. So, you know, if there was an impact on tunas, we may not have seen it yet. So there are differences. But again, doing the experiments we're doing on mahi, you know, doing that on bluefin tuna, good luck. It's just not, you can't do it. I mean, very few things are impossible, but that probably is very close to one of them.
Yeah, Dr. Grosell, you mentioned you dosed them at an environmentally relevant rate.
Yeah.
Were you at constant rate for that for 24 hours?
Yeah. So the question is, well, you repeated a statement I made that we exposed them to environmentally relevant concentrations, and then your question is whether that concentration was constant over 24 hours. And I first want to address the environmental relevance. So the concentrations we used were certainly measured in the Gulf of Mexico during and after the spill. But by far the majority of the samples collected showed concentrations below that. So it all depends on who you are, frankly. You know, BP will tell you that those concentrations are not environmentally relevant. I argue that they are within what was measured in the environment, so they are environmentally relevant. You know, so but that's, you know, we're pretty much past that discussion now after the settlement, which is nice. And now your question about whether those levels are constant during exposure, they're not. These pHs are volatile, the low molecular weight ones, and the high molecular weight ones, they stick to anything that has any lipid in it, for example. So they adhere to plastic surfaces, they'll stick to the biology they accumulated by the animals during exposure. So we can actually get a depletion over 24 hours of about 90%. And that's taken into account. The concentrations I'm reporting is sort of it's not really a mean, it's what we call a geometric mean that takes into account that the decay is exponential. But we don't actually really know whether it's the first hour of exposure to very high levels or it's the remaining 24 hours of exposure to lower levels that's really causing the toxicity. We've addressed that on early life stages where it's a little easier to handle, and it looks like there are certain windows of enhanced sensitivity right around hatch in those life stages. But in general, my impression on the later life stages is that you do need the long exposure to lower levels to really see the effects. Because a very short exposure to high levels will not elicit the type of responses we see here.
Is there any idea of how many barrels of oil are released using natural seepage versus how does that compare?
Yeah, our estimates are that the question is how does the release of oil from natural seeps compare to the Deepwater Horizon event? It's about 10% per year, rough numbers, of natural seepage. But you have to keep in mind that that's dispersed across, you know, several 100,000 kilometers of ocean. And it goes forward 24/7, you know, 365 days out of the year. Whereas the release of oil from Deepwater Horizon was concentrated in one place and went forward for 84 days, more or less. So it's a very different sort of comparison. But if I could just speak to it a little bit more, one of the things that was put out or discussed and remains a point of discussion was the microbial response to the oil. And it was stated that, well, the Gulf has got all of these natural seeps, and therefore the ecosystem is developed or evolved to cope with that kind of insult. And it is true, as Vernon alluded to, and I have also seen through my work, that at natural seeps you can have lush communities of organisms that thrive based on the carbon which is supplied, from that oil. However, those communities take centuries to reach, full function. And the idea that the water column will respond in a matter of hours or days to that is apples and oranges. So there is a huge, difference between the natural supply of oil, although I wonder, and my question to ask Dr. Grosell about the exposure of fish at these sites, there's a huge difference between that. It's apples to oranges. And the Gulf, is not inoculated with a bacterium that, can spring into function and remove the oil. Human beings create oil spills. Mother Nature cleans them up, and we basically just stand by and watch.
Yeah, I can just add to that, actually. It's a good point. We are doing studies in the lab now where we're looking at whether prolonged exposure of parents will lead to fish offspring that's more resistant to oil contamination. And the data so far is encouraging in that offspring from exposed parents are more tolerant to sort of subsequent acute challenges with oil. And that is relevant for the Gulf of Mexico. Now, we don't know if the natural seeps occur at an extent and a density that's high enough to elicit this response. But the Gulf is an environment where there is natural exposure to PAHs. And it's not, but based on our data so far, it's not inconceivable that the fish populations in the Gulf of Mexico have slightly higher tolerance than you would see in other environments. But stay tuned. We're working on that.
For Dr. Grosell, so with your study of the mahi, those that had decreased performance due to the exposure, do you see any recovery back towards health over time, and at what kind of rate?
So the question is whether these animals that show reduced performance, if they can recover if you terminate exposure. And the answer is we have not been able to do that on mahi. One of the problems with mahi, and one of the good things also, is they grow extremely fast. So if we want to do these swim trials on an animal of a given size and then recover them for, say, a month, they're going to be about 2 to 3 times bigger than they are at the time we're doing this. So not only do we have limitations with the technology of then being able to do the same measurements, we also have the problem that swimming scales with size, and all these metabolic parameters scale with size. So those experiments are hard to do. However, we've done it on red drum, which is one of the other species that we work on, and again, prevalent throughout the Gulf of Mexico. It's certainly impacted by the oil spill. Red drum, we can do these experiments on. And the exposures on red drum so far suggest that, say, 1 week after exposure, they're still impaired. In fact, they're even more impaired than they are right after exposure. At 6 weeks, there's no further impairment, but there's no recovery either. So in a 6-week period, we can say, no, they're not recovering. And then that brings us back to the tagging experiments we're doing, because my argument will probably be that, if you're not recovering in 6 weeks, it actually doesn't matter whether you can recover in a year. You're not going to have the chance. You're going to have other problems. But that's my personal opinion. We don't have any data on that.
I would like to thank all 3 of you for sharing your fascinating research with us. And I would like to ask any one of you if you could share what you know about the efforts to prevent oil spills in the first place. What are they doing? What's going on as far as those efforts?
I'm taking the time.
Well, there has been a very whole-scale review of, how we monitor and how we respond. The degree to which the regulations have been rewritten. Perhaps one measure of this is to compare the Deepwater Horizon oil spill with the Exxon Valdez oil spill. Exxon Valdez oil spill released a fraction of the oil, but it had extreme consequences for the environment just because of the different presentation of the oil. But the political response to Deepwater Horizon was very different from the political response to the Exxon Valdez, because the Exxon Valdez was in 1989. By the end of 1990, the Congress had signed and the President had passed the Oil Pollution Act of 1990, which completely rewrote the regulations for how oil should be transported. It mandated double-hulled tankers. It presented all these other constraints and restrictions. It regulated, who would be in charge. It gave very specific role to the Coast Guard, to the responders, the responsible parties, etc. It was a, very comprehensive act which we still live with. There is, unfortunately, no similar legislation enacted or present, and I think that's very much to our detriment.
I have a question for Dr. Grosell. On tolerance is higher in offspring. Is performance in offspring reduced relative to a control? So I think they're talking about the offspring going back. There's a little bit of delay.
Right. Oh, so this refers...
You talked about the offspring are
of
showing...
exposed parents, and that they might be more tolerant?
Yes. And so are those offspring, do they have overall reduced, offspring reduced relative to control performance reduction?
Right. So the question is whether the offspring from parents that have been exposed, I mentioned earlier that they're more tolerant to acute exposures, and by more tolerant I mean they're not dying at the same concentrations, and it takes more to kill them, basically. But the question is, the way I interpret the question is, what about other performance matrices, like swimming, for example? That has not been done. And just in general, as a biologist, when you see something like this, when you see a response to a selective pressure that leads to enhanced performance in one area, it always comes at a cost. Physiology and biology is always a compromise. So you may become better at X, but you've lost an ability somewhere else. We don't have any data on this particular instance, but that would be my guess. So it may be a great thing in the Gulf of Mexico if animals are adapted to oil and can cope with slightly higher concentrations, but it may render them more sensitive to, say, hypoxia or some other environmental stressor. Again, no free lunch, except for you guys later today.
Time for one more question.
Actually, you mentioned 2 to 5 trillion fish died. How do they come up with that number?
So the question is, how do they figure out that there's 2 to 5 trillion fish that died in the Gulf of Mexico? So that takes a lot of modeling, and it takes a lot of population insight and stuff. That's not what I do. So I should probably stop talking right now. But I can't. So I can tell you that what we contributed was, of a given number of fish, how many will die under a certain set of conditions, right? So then you take that information. You then marry that with information about exposure in the environment, which we've seen is very complicated. What was where and when and how much and how long did it stay. And then you've got to, on top of that, say, okay, how many fish were out there and how long did they stay and how much were they exposed, and then take the whole numbers about how sensitive they are. And then you come up with 2 to 5 trillion.
Gotcha.
So it's a modeling exercise with a lot of uncertainties and a lot of components going into it. So
That's why it's 2 to 5 trillion. That's why the 2 to 5 trillion, yeah.
It's actually a pretty narrow range if you consider all that. But there's uncertainty associated with that number, of course.
Thank you.
Okay, well, I'd like to thank our speakers again. So we're not done just yet. No lunchtime just yet. For those of you online, Steve is going to go ahead and put a link to an evaluation. So if you can click on that link and fill out the evaluation, we really appreciate it. That's pretty much how we drive these seminars. We get input from our audiences and decide what topics to do next. At this time, I'd like to say a big thank you to Laura and Sharon, who are part of the CARS Consortium and who have actually helped me with this seminar and get this room and lunch, and they were a big part and helped us to coordinate this whole thing, so we'd like to give them a thank you. So for those online, this ends your portion of the seminar. Again, so thank you for joining us. Everything that you have seen or heard is recorded. I'm going to repeat that again, is recorded and will be on our website within a week or so. So you'll be able to go back and see these videos and hear these presenters speak again. And also, for those of you who are online and cannot join us for the afternoon lab tours, I'm going to plug again Dispatches of the Gulf. They did a great documentary with Brian House and Dr. Martin Grosell, and they did great short films on both of their labs, so you can virtually go to the labs and pretend you're there with us. So thank you again for joining us online. For those of you who are in-house, we also have evaluations. And good news is we have lunch for everybody. Bad news is you're going to fill one of these out and you have to turn it in before you get lunch. So this will be your meal ticket. Again, this is just for our own personal preference. We go back and look at these, see how you guys liked the seminar, what you liked, what you didn't like, and we go forth, again, just for our own personal preference to see how we can make them better and what other topics you guys might be interested in so we can fuel our next seminar. So I will pass these out. If you can fill them out, that'd be great. Again, we still have the lab tours after lunch. They are scheduled to start at 1:10. So lunch is going to be outside. You're more than welcome to bring it in here and eat. And we'll have an hour for lunch, and then we will split the group up at 1:10, and we'll head over to Dr. Grosell's lab and Dr. House's lab, and we'll go in two groups. We'll split you guys into two groups, and we'll each go to a different lab and then switch midway through, and then that'll be the conclusion of the seminar. So again, I'm going to pass these out. Everybody have a pen. If you don't have a pen, you can raise your hand. I have some extras, and please fill these out. And then once you fill them out, please, you can put them at the back table, and then go ahead and make your way out to get some lunch. You don't have to fill. Speakers don't have to fill.
Thank you again for joining us remotely. I'm going to shut down the WebEx. If you'd like to complete the evaluation, the link is in the chat box. We probably will also email that to you as well. Again, we appreciate you participating remotely, and we look forward to seeing you maybe in person at a future seminar. Take care.